Welcome to question 6 of the 2017 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 6 we have let tan theta minus 1 multiplied by sine theta minus root 3 cos theta multiplied by sine theta plus root 3 cos theta equals 0. And for part A, we're asked to state all possible values of tan theta. So first of all, we can see that the null factor law would apply to this equation as it's three things all multiplied together equaling 0. So we're going to consider first up tan theta minus 1, and the null factor law would tell us that tan theta minus 1 could equal 0. Next, we're going to consider the next bracket, which says that sine of theta minus root 3 cos of theta could equal 0 according to the null factor law. And finally, the last bracket, which we're going to do in purple, says that sine of theta plus root 3 cos of theta could equal 0. And now we need to work from these starting points to find all possible values of tan of theta. So in the blue, tan theta minus 1 equals 0 gives the easiest solution, and that is that tan of theta could equal 1. So that is one of the possible values for tan of theta for this question. Next up, we have that sine of theta could equal root 3 cos of theta, and we just added root 3 cos of theta to both sides of the equation to find that. And now if we divide both sides by cos of theta, we find sine over cos is equal to tan, so we find tan of theta could equal root 3. So that is another possible value that tan of theta can have for this question. And now applying a similar logic to the third part in purple, we have that sine of theta could equal negative root 3 cos of theta, and then dividing both sides by cos of theta, we find that sine over cos is tan, so tan of theta could equal, and on the right hand side we'll just have negative root 3. So that is the other possible value that tan of theta could equal for this question. From the examination report we can see that 25% of students got full marks for this question, and that overall the question was not answered well. Students struggled to find solutions beyond tan of theta equaling 1, which was the simplest one to find. And it's important that students are encouraged to read the question carefully so as to recognise what is required of them. A number of students went beyond what was asked of and attempted to find the values of theta, which was not required. We just needed the values of tan of theta. Some students who managed to obtain 1 and root 3 gave the third value as 1 on root 3 instead of negative root 3. For part B it says hence find all possible solutions for this equation equaling 0, where theta is between 0 and pi. So first of all, it's important that the word hence is inviting us to relate our previous answer to this question. And to do that, it is simply done by recognizing that this factorized form here can be further factorized to the top line. So that is, the equation we're solving here is actually identical to this one. And you could check that by either expanding the top line or factorizing the second line and seeing that they are equivalent to each other. So now, based on what we found from part A, we know that tan of theta equaling 1 will lead to solutions for that equation. We know that tan of theta equaling root 3 will also lead to solutions to that equation. And we know that tan of theta equaling negative root 3 will lead to solutions for that equation. And now our job is to find the values of theta between 0 and pi that satisfy each of those tan ratios. So it's up to you how you remember your exact values, but the method that I like is using the unit circle. So I know that tan theta equaling 1 is this position on the tan line, and that angle there is going to be pi on 4. So for the first part, I can say that theta equaling pi on 4 is a possible solution to the equation. And going between 0 and pi, there's no other angles in that domain that would give tan theta equaling 1. For the green, I know that tan theta equals root 3 up here, which gives an angle of pi on 3. So this will give us theta equals pi on 3, and there's no other angles between 0 and pi that give tan theta equaling root 3. So the third thing we need to do is consider tan theta equaling negative root 3, which is down here on the tangent line. And this angle here is also related to pi on 3. However, it would be negative pi on 3, but if we extend it up into this quadrant, it is the same as pi take pi on 3, which is the same as theta equaling 2 pi on 3. So the solutions for theta for this question, if we just summarize them here, are pi on 4, pi on 3, and 2 pi on 3. So they are the answers to part B of this question. From the examiner's report, we can see that 1/4 of students got full marks for this question, and that the examiner goes on to say that this question was not handled well. Many students did not follow the instructions hence, which was an important note that allowed you to connect this equation to part A, but some still managed to find some of the solutions to the equation.